a pleasure for me to be able to provide you the results of this project Hercules that seems to have quite a big resemblance with the objectives of the Berlin universities trying to associate and to join efforts to provide better knowledge graphs or information systems to model the academic and the research domain. So as a matter of fact, this is the purpose of this project called Hercules. As you can see on the slide, I also wanted to put the name of Reyes Hernandez Mora Martinez, who is the person from University of Murcia that has been behind the orchestration of this project. In this project, different companies and universities have taken place. As a matter of fact, the work that I'm going to be describing today about the network of ontologies that we created within Hercules was materialized by this association between a company called GNOS and the university I represent, the University of Deusto, where I am full professor in the research group MORLAB. Okay, so first of all, I'll give you some context about the Hercules project. This is an initiative promoted by the Conference of Chancellors of the Spanish Universities. It's been coordinated by the University of Murcia, and it was allocated 5.4 million euros, from which 80% came from European Regional Development Funds. The Ministry of Science, Innovation and Universities of Spain is also behind the project, and this project began in 2017 and is finalizing right now. Okay, so why did we create Hercules? Why, in this case, this commission of universities in Spain first picked Murcia as the university that would lead these efforts towards getting a holistic knowledge graph about the academic world and academic research in Spain. Well, so the situation is that 84 universities have their research management system, their, in other words, in other contexts called CRI systems. Each university has its own procedures, and systems are based on different data models and schema data. There is very low or poor standardization. The transfer of research results to society is done regretfully in a disaggregated manner. There are therefore inefficiencies in the way that knowledge is managed and disseminated, and also a lot of effort has to be put into aggregating the information coming from different sources, from different information systems. If you don't have a good information management system, then you may lower your opportunities to be competitive in the challenging research domain and context of Europe. And regretfully, data representation is done with very different granularity. There are very big details about, for instance, publications. There are very few details about, for instance, research projects, funding, and other aspects which are also interesting. So Hercules is born to try to address these contexts, these aspects that I'm commenting. So besides, it had to take into account several important requirements. In Spain, we have a so-called normalized curriculum vitae. So every researcher that is applying for a grant must submit her CV in this normalized format. So there is a kind of a standard de facto on how curricular information is published. Well, we would like to share knowledge between the different universities. I myself represent a different university to University of Murcia, in this case, the University of Deusto. We want to foster the collaboration between universities and research groups, and probably this could be improved if we were available, if we were ready, if we were capable of representing our knowledge domains with their associated research objects behind within a holistic knowledge graph. We have to unify the criteria used to extract the information. We should provide open access of the research results to the society. Also, we have to bear in mind that we have to mix information coming from diverse universities who have very distinct information management systems, and hopefully also by trying to give sense to all of this, we would like to improve the technological transfer and collaboration between universities and companies. So these are basically the big highlights of the reasoning why this basically the Commission of Universities of Spain decided to launch this project. So what did they do? So basically this HÉRCULES project has been about first creating what we call a semantic architecture and research ontology. Is the sub-project called ASIO. Today I'm going to be talking to you particularly about this important sub-project, which is basically the backbone of the whole infrastructure that has been created. Then on top of it, this project, not my organization, another organization and companies, another cluster of organizations has created an innovative research information system of CRIS that makes use of the semantic model of the knowledge graph created within the project. Then, once we have this research information system, the project has created some tools to basically enhance the possibilities of distilling information out of the scientific, academic research information available in the Spanish universities. This is the so-called National Research Portal, which basically includes a section to perform advanced searches, also another section to create dashboards with research indications, and another one that allows you identifying potential partners with whom you could create new proposals and submit projects. And finally, the last piece of this jigsaw is the tool for the management and enrichment of researchers' information. Well, this has been basically the last piece of infrastructure built by HÉRCULES, and tries to capitalize on the fact that behind there is a very nice knowledge graph that could still be refined, extended, interlinked with data sets, with knowledge graphs that are external to the Spanish universities. Okay. Which we deliver a knowledge graph, we can deliver knowledge graphs, and this information is available through a linked data server. Okay, so on top of it, we also had to take into account the information management needs of universities in general. They have to deal with human resources, they have to deal with economic and academic management. So therefore, the project created a brand new CRIS system, which is compatible with the knowledge graph created in the project. Next, what we did is to go beyond and try to infer new knowledge out of the academic information model in the ASIO knowledge graph, and we took into account other sources of information, like the internal university libraries of the universities, and well-known academic solutions like Scopus, Web of Science, ORCID. So basically, after all, there is a need to map the ideas of resources, of entities modeled in the knowledge graph with external entities modeled by other organizations. So this is the part of semantic enrichment, which is the ED system, according to the equivalent acronym in Spanish. And finally, once we enrich semantically the data, the internal data of the universities with external useful data, we also produce a set of ML-based tools and algorithms that allow us this alignment of resources to be performed, and also to the removal of duplicates and all these kind of important aspects to not only make these knowledge graphs be evolvable, but also to maintain a high degree of quality behind the data model. Okay, so the first and most important part of my talk is about talking about this ASIO solution, which can be defined as a solution grounded on semantic architecture and ontological infrastructure to be used by the Spanish universities, and that offers two main contributions, two main features. So first of all, we have created a network of ontologies that allows you to model projects, to model research objects, to model researchers, activities. I will give further details in the following slides. And also with the premise that we don't have to reinvent the wheel. There is a wonderful, already existing network of ontologies called VIVO that we realized also when we did the work of ROH that was already there. So therefore, all these entities in the academic domain that are already well modeled by other ontologies, they have been imported. We are basically reusing those ontologies. And also, we made sure that in this networking of ontologies, we preserve the FAIR principles, as I will explain later. Besides, we didn't only need to create the model, how to basically model the information. We had to host the information. We had to store it, manage, publish that information. So this is actually the part that the company Genos was in charge of. They also created the ontological network, and Genos provided the infrastructure, the link data server, through which that data, the instance data model according to the ROH network of ontologies could be modeled. So I frame here the actual focus of my talk today, to talk about the network of ontologies that we have created. So in this process of designing this new network of ontologies that models the academic knowledge, we follow the steps, the workflow that you can see on the screen. So first of all, we gather some requirements, and I will explain you now how we did that. Then we also performed a state-of-the-art and identified what ontologies were already available that could be imported, adopted, extended, used, linked with other ontologies. Then we proceeded to the implementation with a common, well-known tool like Protégé of this network of ontologies. And then we carried out the validation that this ontology fulfill certain design requirements that I'm going to be outlining next, because we wanted this network of ontologies to be very usable, to be extensible, to be flexible. I'll go one by one with these kind of requirements, quality requirements that we added. And notice that we also put in place a so-called ontology ops process, ML ops, a DevOps process, so that whenever you perform enhancements, a set of validations were automatically triggered to make sure that changes performed to the network of ontologies still kept all the properties, the quality properties of it. So in more details, regarding the requirement analysis, we were given a set of use cases by the Commission of Spanish universities, some use scenarios that they would like such knowledge graph to allow them to fulfill. Also, as I indicated, step 2, we selected and analyzed already existing ontologies describing the academic domain. Then, once we chose what we needed to model, what relationships between those concepts we needed to model, we using an ontology design tool like Protege, we proceeded and devised the first version of the ontology. And also, once this first draft was produced, we created an evaluation of the flexibility, completeness, and integrity of the resulting network of ontologies. And for that, as I will explain also in forthcoming slides, we carried out 76 competency questions that were proposed by the coordinating team in the University of Murcia, which basically detail complex queries that researchers, managers of research, heads of departments, well, all the stakeholders of an academic system could query or could be interested on. So we verified that the network of ontologies is able to answer all these queries. And also, we were aware that we had to import big amounts of information from already existing research information systems. So we adopted the so-called language to ensure that complex and sophisticated low-level verifications of the contents imported were performed to make sure that the data imported fully comply with the restrictions of the ontology. Finally, another way to test that our network of ontologies is covering properly the academic domain, we produce a tool that maps the standard format of a CVN of a normalized curriculum vitae in Spain into instance data of ROH network of ontologies. And finally, we put in place this continuous integration and development workflow that whenever changes are committed into the network of ontologies, runs a test suite of Sparkle competency questions to validate that our changes didn't break anything in the ontology. Okay, so besides taking as input a set of sophisticated and complicated scenarios, as I anticipated, as I commented, these are the 5 design principles that we took into account before actually starting the design of the network of ontology. First of all, reusability. We don't want to reinvent the wheel. We want to avoid remodeling concepts that are already very well modeled and thought through by other researchers in the past. So for instance, positions held by a person in an academic organization are very well modeled and documented in the VIVO ontology for research and discovery. So we basically imported the way positions are modeled in VIVO of ontologies. Extensibility. Although academic information modeling shares many aspects which are university agnostic and country agnostic, there are some situations in which there are some specific details according to the country where you are. So for instance, in Spain, when every 6 years you have the opportunity to certify the quality of your research by submitting your 5 highest impact journal articles, and a commission assesses whether those publications are of good or not good quality, and if they are of good quality, they basically grant you what we call a sexennium. Okay, so this concept doesn't exist in some other countries. So we were aware that this extension should be made ready only for Spanish universities adopting ROH, but we try to design ROH so that any international university can adopt it. Maintainability. We, as you will see in following slides, we modularize the network of ontologies so that departing from a core ontology, we created certain extensions that are optionally integrated when you basically deploy ROH in a university. Integrity. So we wanted to make sure that we leverage ontological restrictions, and we also created a nice suite of sophisticated SQL scripts to make sure that integrity was preserved across the instantiation process. And finally, and I think this is probably a remarkable feature of our network of ontologies, we wanted to promote usability, because we are aware that the users of an ontology should not only be specialists, should not only be computer scientists, ontologists. They should be standard people that through a common interface make use of it. So we basically, although obviously in the design we took into account the open world principle, we wanted to describe in as far detail as we could the entities and properties of our ontology. And so regarding requirement analysis, very quickly. So these are just 7 examples of use cases that we were provided with, through which basically we had to distill what were the entities considered in those scenarios. So, for instance, they wanted, HÉRCULES wants organizations, universities to be more on top of what are their funding sources, where they spend their money during the execution of projects. So basically this gave place to this wide range of entities that you are seeing here, like project, funding entity, income and types of incomes, expenditure and types of expenditure. Beware that we don't only need to model the exclusively academic information, we also need to model the information that deals with the management of research performed by a university. Then we wanted to identify what were the knowledge hubs in different areas. So basically, given a university or given a cluster of universities, to identify what organizations in what geographical scope were more expert in certain knowledge areas, in certain specialization areas, what were the lines of research, what were the type of publications that they managed to get, and so on and so forth. We wanted to create dashboards so that research managers, principal researchers, those taking decisions regarding research processes and research projects and research publications will have the opportunity to gather together information about areas of expertise, organizations, metrics, even metrics, to model different metrics. So like, for instance, if you want to model the impact factor of a publication. We also wanted to create a search engine at national level. I already indicated in a previous slide that one of the sub-products of HÉRCULES has been the creation of such a portal, but we needed to model the information that you see here. We also wanted to help researchers to automatically configure candidate suitable partners in different expert areas, in different areas of expertise. So here again, we need to model the entities that you see here. We also wanted this knowledge graph resulting from this network of ontologies to be able to help people identifying new research opportunities. So we are able even to model calls for proposals. When a project is basically granted, this project is tagged or is linked to the actual call for proposals or call a topic it was funded from. and we can also tag what research groups took part in what projects, under what role, and so on and so forth. And we also wanted to be able to automatize certain research management duties, like, for instance, automatic generation of researchers' pages, automatic generation of research groups, automatic generation of research reports of an organization during a period of time. Okay, going back, still more kind of requirements, quality requirements that we put on the table before we actually did the design of this network of ontologies. We had to comply with the linked open data principles, and we wanted to give place to a 5-star data sets, which basically are contain entities that are linked with each other, apart from being uniquely identified and addressable by an URI. Besides, we wanted our resulting data sets to follow the FAIR principles, to be findable through persistent identifiers, accessible through HTTP, interoperable, adopted already existing vocabularies, and reusable, published using open licenses to promote reusability. And we've done that, as I will show next. We wanted to use persistent identifiers. One of the problems that sometimes you encounter when you design a network of ontologies is that you spot some previously created ontologies that suddenly disappear. They are not hosted any longer anywhere. Okay, so we made sure that we use persistent it is, and also we also contain copies of such adopted ontologies, so that in time the ROH network of ontologies could survive these events. Of course, providing that the underlying licenses of those ontologies allow us to do so. We also wanted to make a multilingual network of ontologies, because in Spain, apart from Spanish, there are some other co-official languages like Basque, Catalan, or Galician, and we therefore did that, and we made sure that all the resources, all the entities were labeled in English, Spanish, and the co-official languages. We wanted to interoperate with existing ontologies. Definitely, this is a must in the good design of a network of ontologies. And for those ontologies that are no longer available, we made sure, in order to prevent this problem, we made sure that they are hosted by ROH itself. We also wanted this network of ontologies to be able to talk to existing CRIS or research management systems, and also to be linked to the useful knowledge graphs provided by DBpedia or Wikidata. And finally, we released this network of ontologies under this open source license that I'm pointing there. This is hyperlinked. You can access to the details of the license. I will share the presentation with all of you after the talk. Okay, so this is a big diagram that's trying to show most of the things that we model, and I repeat, only most of the things. There are more, but we can, having a closer look, see some of the important entities that we identify there. So, for instance, we identify that there is a very important entity, which is the so-called project entity, and a project entity has to be linked to funding organization. It has to, it may have certain funding. That funding may have been obtained through a funding program promoted by a funding source. You may receive, as part of the funding, several amounts, give place to several expenses. So as you can see, it's a very exhaustive way of modeling project. In a project, people take place, organizations take place in the projects. You may have to sign contracts whenever you basically start taking part in a project. People are subject to different accreditations, as we call it in Spanish, and they may play different roles within an organization. An organization and a person may be involved in different knowledge areas. As I already indicated, an organization may also take part in different roles. And very importantly, we also need to model research objects, which is an emerging standard to basically promote open research. So we are able to model not only publications, which is a very important part of research objects, but also software datasets, patents, reports, okay? And of course, dissertations in all the different types of dissertations that we can encounter. Besides, we had to model activities, attendance to a conference, intercepts of people, also geographical scopes where a project or a person is associated, and time intervals in which activities, positions, roles are basically played by a person. So this is a very quick overview of the exhaustive ontology that is behind the network of ontologies of Azure. And here, as you can see, it is hyperlinked to our documentation, where you find all the namespaces, all the external ontologies that we have imported into this network of ontologies. You have some details about the design rationale. You have this diagram that I'm showing to you now. And most importantly, very importantly, you have an exhaustive description of the most important entities by this network of ontologies. In a tabular form, you have all the relationships, all the so-called object properties, all the data type properties, and also diagrams showing basically what is the relationship of a given entity with all the other entities. So regarding modularity, we don't have a monolithic ontology. There is a very important part, the so-called core module, that contains the descriptions of the main entities, those ones that are agnostic to a given university or country, but we have a set of vertical modules that try to basically add further details. So, for instance, we want to be able to specialize certain academic concepts, as the one I mentioned before about the sexennium, or we could also model academic positions. We don't have in all countries exactly the same kind of hierarchical academic positions, although they are more or less equivalent. So in this case, for instance, we have provided an extension module, a vertical module, that allow us to define human resources according to Spanish universities. And we have also adopted extensively a good range of taxonomies to be able to classify certain entities without having to go through very complicated and less flexible hierarchical classes. So this is an outline of what is the core module and all the vertical modules that we have provided in different complementary aspects of the core ontology, ontology forming part of ROH network of ontologies. You can notice there some statistics about the number of classes, actions, and so on of the network of ontologies. In here, again, I show you a listing of all the ontologies that we have imported. So you can notice here that VIVO is actually a very important ontology used within the ROH network of ontology. As a matter of fact, 46 classes have been used within ROH. And of course, we have created some entities ourselves. As a matter of fact, 144, those ones that are correspond to the prefix ROH. Okay, so as I stated, for us, we wanted this ontology to be usable, to remove as much as possible the uncertainty, so that somebody making use of it wasn't given too much freedom so that they would instantiate entities of the corresponding classes in a wild manner. So we populated the ontology, the entities with different ontological constraints, but also we made use of defined classes, which basically are some kind of virtual classes where an instance belongs to one of those virtual classes whenever they fulfill a set of constraints or restrictions. So we created defined classes for important entities, like for instance, research object, accredited issuer, or funding organization. Here you can see that a research object must have a corresponding author, a knowledge area, and may with an or be produced by a project. These are some of the restrictions that might be associated to a research object. We also made extensive usage, as I said, of taxonomies. So we often link projects to project classifications through this property that you can see here. Okay, of course, there are many details, but we have put a lot of effort generating a very exhaustive documentation. So some documentation was generated automatically with tools like Widoco, and this is the actual automatically generated documentation of ROH. But also we produced some manually created documentation. That is the one I showed you as GitHub pages, very extensive. And even more handy, we created a PDF where you can per entity browse all the data properties, object properties, and relationships with each of their corresponding or correlated entities. Good. So now I'm going to go extremely fast through some of the concepts we model. These slides are placed here only as reference. So if you want to have a look into it into more detail, you will have them available. But anyway, zooming it, you can see here how we can model a project. So a project has all these data properties that you see here: an identifier, application, description, title, and it may produce, as you can see, many research objects. An organization may play different roles in a project. For instance, it can play an administrator role in a project. The project may have a status. It might be accepted, ongoing, completed. It may have a geographical background. It may be valid through a range of time. It may be linked to different categories. So it may be a European project. It might be a Spanish project. It might be a public funded project. It might be a privately funded project. It may be associated to different knowledge areas. Many people may participate in the project under different roles. As you can see here, a project may have a contract. A project may be part of another project. Within a project, you may carry out different activities. You may incur into different expenses, and a project may be associated to different funding. So as you can see, it's a very complete and exhaustive way of defining projects. And in here, you cannot see it very well, but basically you have further details about all the valid object properties and data type properties per entity. And every time we design something, we had to basically answer why or what kind of competency question such entity would need to address. So in this case, for instance, we validated that this VIVO project entity is properly modeled within ROH by giving answer to the 66 questions that we have were given by Murcia University that deal with projects. So for instance, one of them could be this one: return the research project proposals addressed to a company, including economic details of the research proposal, the proposed funding, and the associated funding amounts. It's quite a complicated query. This is an example in generic terms of how the underlying information of a project is modeled with triples, and this is a potential query that would address this question. So as I said again, and I will I hyperlink it later on, for each, well, we have 66 competency questions that basically validated that we are we fulfill completeness, that we can address and model every information needed by the Commission of Universities in Spain with our network of ontologies. We also model people. I don't think we have time for me to get too deep on the details, but again, it's the same story. A quick thumb. So a person may be awarded, may have several degrees. You may be working under a contract. You have a curriculum vitae. You may play different positions in an organization. Each position has a time boundary. Normally, there may be several metrics. For instance, the age index of a person, of a researcher. You may teach different academic subjects. You may play different roles in projects. You may have several contact information. You may also, in the Spanish case, be linked with the sexenios or sexenium, where basically they certify your quality as a researcher, and you may be expert on certain knowledge areas. So again, here there is a question that could be addressed, an example of question that could be addressed by the fourth person entity that we introduced in our network of ontologies. Given a person, list the research projects to which he or she has contributed, filtered by period or organization. We don't have time to go in low-level details, but in here you have proof of some of the queries that would allow us to extract that information from the knowledge graph. Well, and the same happens with organization. I'm going to skip it. The same happens with funding. I think funding is an area where we have gone quite far, because we needed this knowledge graph to be used also by the research management systems of the universities. So you can see that we have defined funding programs, funding organizations, funding sources, funding amounts. So it's a very thorough way of depicting all the information lying behind certain project funding. We also paid a lot of attention to research objects, and a very good example of research object is an academic article. We leverage from a well-known ontology to model publication, which is VIVO, and well, basically we can model absolutely everything about a research object, including, very interestingly, the fact that we can also link it to metrics. For instance, an academic article may have a certain impact factor, okay? And the same happens with other types of research objects, like data sets, software releases, and so on and so forth. We also model activities a researcher or somebody working for a research organization may be involved in. And okay, the last step that we did in this design of ontology was to create a very rich collection of Sparkle queries with diverse competency questions. And this is actually publicly a repository. I am now trying to access it. And you can see each of the queries that we perform. And also you can see the result that was obtained after performing those queries. Very interestingly, we also have given place to two instance data sets, two knowledge graphs. One is synthetic data set, which basically has instances of all the entities and all the relationships that we have modeled, and another which is a real data set, which is based on our research group, on the publication researchers projects where we have been involved, which is not a huge data set, but is a considerable data set that proves that this network of ontologies, here you have the instance data, is able to model this kind of information. We continue the validation, and we made sure that CV written according to the normalized curriculum vitae standard of promoted by Spanish academic institutions can be ingested by ROH, giving place to ROH instance data. And also, we also did the loading of dumps of CRIS datasets into ROH. So we took as input datasets compatible with Serif or the custom-built research management system produced within HÉRCULES. Finally, we also, as I already anticipated before, created, and I think this is quite interesting because we try to make more professional the maintenance of this network of ontologies. We created a continuous integration and development and deployment workflow. And essentially, this workflow sets the environment to basically launch an ontological reasoner, which is in this case is Pellet, load there the synthetic data set, launch, get the queries and the data sets from the ROH repository, execute all the competency questions, make sure that they all pass the tests, and if that's the case, we generate automatically the documentation of the whole project. If you are interested in this process, it is freely available again in the repository of the project. So we have produced ASIO, but this was just a part of the jigsaw that had to be completed with a custom-built research information management system that makes use behind of the knowledge graph enabled thanks to ASIO. And there you can see what kind of things this RIS system can do: research group management, scientific production management, well, the typical functions provided by a research information management system, usually compatible with the Serif standard that is pointed out here. One sec. I wanted to point this Serif. Okay, good. Also, as an interesting side effect enabled by the knowledge graph that we've been able to create, now other partners have produced a research portal that helps universities exploit research information, facilitates the detection of research and development synergies with other universities. So basically allows you to do sophisticated faceted queries of the knowledge graph, and also to create dashboards with it. And also we have the project has put in place this other extension, which is able to not only take in as input the CRIS, the current research information system of an organization and its knowledge graph, but also external, very important information, like the one provided by Scopus, WOS, Fixer, Slicer, and so on and so forth, in order to be able to continuously enrich, align, eliminate duplicates in the resulting knowledge graph. So now I'm just definitely finishing with this project, and particularly with the ASIO part, where my University of Deusto has contributed. I think we have delivered an innovative product that incorporates semantic web technologies to allow us to pass from data to actual information to facilitate decision-making processes for those stakeholders in the different universities. This is an open source software. You are all invited to make use of it and to contact us in case you want to do any extensive refinements, corrections to whatever we provided. This is the web page from which it can be basically cloned, forked, whatever you want. There are full details in this repository. We hope that HÉRCULES will eventually improve the efficiency of research management, the efficiency in public investment, and hopefully also even the efficiency of research, because the researchers themselves may also be target users of the solution. And hopefully with this, we will enhance, standardize scientific dissemination, be able to detect research development, innovation synergies, and we will progress towards academic analytics to actually try to understand better where we are in the research domain and with whom and how we can contribute. And this is definitely my last slide. So thank you for your patience.